Random errors and systematic errors are both types of errors that you need to know. An error is just a difference between your result and the expected value. A random error is when measured values vary randomly around a true value, and they usually occur in experiments due to human error and random variations. So for example, this could be when a person has trouble reading the scale of an instrument and makes a mistake, or when the environment changes. So things like the lab getting warmer and cooler during the experiment, which results in the readings being affected. You can reduce the effect of random errors by taking several measurements and calculating a mean. Systematic errors, on the other hand, is when there's a consistent issue in the experimental design or equipment, which causes the measured value to always be too high or too low. So for example, this could be when you forget to reset a scale to 0, meaning all of your mass measurements are off. This is known as a zero error, and it's a type of systematic error. Uncertainty is all about how confident you are in a measurement that you take. It's a number that tells you how much your results might be off by. They're represented with a number followed by a plus minus sign, followed by another number after it. The first number represents the value, and the second number tells you how much that value could vary by. So if you had 8 plus or minus 3, then your value could be anything between 8 minus 3, which is 5, to 8 plus 3, which is 11. The way you find the uncertainty of a measuring device depends on whether the device is analog or digital. Analog instruments are ones that use a scale or a pointer, and a person needs to read off the measurement, whereas a digital instrument is one that has an electronic display to show the measurement as a number. In analog instruments, uncertainty is usually half of the resolution. The resolution is just the smallest thing that you can measure using the scale on the device. So if you have a ruler where the smallest division is 1 millimeter, your uncertainty is half of that, which gives plus or minus 0.5 millimeters. For digital instruments like a digital clock, it's much simpler. The uncertainty is just the smallest number that the device can display. So for this stopwatch, it would be 0.01 seconds. You can also calculate uncertainties for results that you've obtained from a series of experiments. All you need to do is find the range of the readings and divide it by 2. The range is just the difference between the highest and lowest value. So if we carried out an experiment and got results of volumes as 25 centimeters cubed, 31 centimeters cubed, and 26 centimeters cubed, the uncertainty would be the range, which is 31 minus 25 divided by 2. This gives an answer of plus or minus 3 centimeters cubed. Okay, now let's try a quiz on this topic. See how many questions you can get right. If you liked that video and want to see more, remember to subscribe to Flash Revision Lab to get notified every time we release new content.